Beneath our planet's shimmering ocean surface, extraordinary creatures have quietly endured for countless millions of years. Sea turtles navigate these waters with grace that belies their remarkably ancient and mysterious evolutionary origins. Their story stretches back hundreds of millions of years through survival, adaptation, and profound evolutionary transformation. These marine reptiles have withstood asteroid impacts, shifting continents, and the rise and fall of life's empires. Tonight, we embark on a journey into deep time to uncover sea turtles' hidden evolutionary history. We will trace their rise from terrestrial ancestors to the magnificent oceanic monarchs we cherish today. We will explore why their survival matters more than ever in our rapidly changing modern world. The dawn of Testudines. Modern sea turtles belong to a remarkable ancient lineage known scientifically as the order Testudines. This diverse order encompasses all turtles, tortoises, and terrapins that are alive on Earth today. To understand these marine giants, we must first glimpse the origins of their broader family tree. Their tale is as complex and mysterious as the vast oceans these creatures now inhabit. For centuries, scientists have debated exactly where turtles fit in the grand tapestry of life. Recent discoveries have uncovered revelations that challenge long-held assumptions and illuminate evolution's extraordinary ingenuity. For decades, scientists believed turtles were primitive, almost isolated among all other living reptile groups. Their skulls are marked by an unusual absence of temporal openings found in most reptiles. Some researchers classified them as surviving relics of Anapsida, a primordial and ancient reptilian lineage. Yet, new genetic and anatomical studies reveal a far more intricate and surprising evolutionary truth. Turtles are not ancient anomalies, but highly specialized members of Diapsida, a diverse reptilian group. This group also includes lizards, snakes, crocodiles, dinosaurs, and even all modern bird species today. Their skulls tell a fascinating story of evolutionary experimentation spanning hundreds of millions of years. A convergent loss of features makes turtles uniquely adapted to their varied environmental niches worldwide. The fossil record offers tantalizing glimpses into the earliest stages of turtle evolution across deep time. In the Permian period, roughly 265 million years ago, remarkable creatures began emerging. A creature named Eunotosaurus emerged with broad, flattened ribs hinting at the protective shell yet to come. Its distant cousins, such as Pappochelys and Odontochelys, reveal a patchwork of transitional evolutionary traits. Semi-aquatic habits, fused belly ribs, and earliest hints of carapace development testify to evolution's slow dance. Here, the turtle shell was not merely a shield, but an innovation forged gradually over millennia. It stands as a testament to the remarkable adaptability and resilience of life on Earth. These STEM turtles illustrate a surprising narrative that challenges our understanding of marine turtle origins. The shell first evolved for terrestrial or burrowing lifestyles, not initially for life in the sea. Fossils from the Triassic and Jurassic periods reveal a fascinating mosaic of experimental evolutionary adaptations. Some species retained teeth inherited from their ancestors, while others developed powerful curved beaks instead. Some had partially fused shells offering limited protection, while others displayed broad protective rib structures. Each discovery fundamentally reshapes our understanding, revealing a nonlinear and almost experimental evolutionary process. This process defies simple explanations and demonstrates the complexity of evolutionary innovation over time. The transition from land to sea was gradual, with multiple lineages experimenting with aquatic lifestyles. Odontochelys, discovered in China, possessed a belly shell but lacked a complete carapace on its back. This suggests that shell development proceeded in stages, with ventral protection evolving before dorsal coverage. The rise of marine turtles. Fast forward to the age of dinosaurs, and the first true marine turtles begin to emerge. The lineage we recognize today as sea turtles likely originated in the early Cretaceous period. This emergence occurred roughly 120 million years ago in ancient prehistoric ocean environments. Fossil evidence of Desmatochelys, a 2-meter-long ancestor, shows early adaptations for open ocean life. Yet these ancient creatures retained hard-shelled eggs reminiscent of their terrestrial forebears' reproductive strategies. These ancient mariners set the stage for incredible diversity of marine turtles flourishing for millions. By the late Cretaceous, sea turtles had diversified into numerous families with varied ecological niches. Some evolved massive sizes, while others developed specialized diets ranging from jellyfish to hard-shelled mollusks. The warm, shallow seas of the Cretaceous provided ideal habitats for these remarkable marine reptiles. Some ancient sea turtles grew to astonishing sizes that dwarf even the largest modern species. Archelon, a colossal relative from the late Cretaceous, could reach lengths of over 4 meters. It dominated the seas with a presence both awe-inspiring and formidable to contemporary marine organisms. Yet, despite their massive size and evolutionary success, these creatures were not immune to catastrophe. The Cretaceous extinction event, triggered by an asteroid impact, wiped out countless marine species worldwide. This cataclysm eliminated numerous sea turtle lineages, leaving only a fraction to persist in modern times. The survivors were smaller, more adaptable species that could withstand rapid environmental changes and disruptions. These resilient lineages became the ancestors of all 7 sea turtle species alive on Earth today. Modern sea turtles and their adaptations. Today, sea turtles belong to 2 surviving families that represent millions of years of evolution. Cheloniidae includes 6 of the 7 living species, each adapted to specific oceanic environments and niches. Dermochelyidae is represented solely by the leatherback, the largest and most distinctive living sea turtle. Cheloniids possess rigid, keratin-plated shells that provide protection from predators and environmental hazards throughout life. The leatherback boasts a leathery, flexible carapace reinforced by thousands of tiny, bony osteoderms beneath. Each adaptation reflects a long evolutionary history sculpted by environmental pressures, predation, and oceanic demands. Green turtles graze on seagrass meadows, maintaining healthy ecosystems through their constant herbivorous feeding behavior. Loggerheads possess powerful jaws adapted for crushing hard-shelled prey like crabs, mollusks, and conchs. Hawksbills use their narrow beaks to extract sponges from coral reef crevices with remarkable precision. Leatherbacks dive to extreme depths, hunting jellyfish in the cold, dark waters of the ocean. Each species plays a unique ecological role, contributing to the health and balance of marine ecosystems. Their migrations span thousands of miles, connecting distant ocean basins and coastal habitats across the globe. Sea turtles are not just icons of the ocean. They're vital players in ecosystems. From maintaining healthy seagrass beds to supporting coral reefs, their presence shapes life beneath waves. Their grazing behavior prevents seagrass from overgrowing, promoting biodiversity and nutrient cycling in coastal areas. Their nesting activities transfer nutrients from ocean to land, enriching beach and dune ecosystems significantly. Yet, despite millions of years of resilience, these ancient mariners face unprecedented modern environmental threats. Habitat loss, destructive fishing practices, and climate change now imperil species that once weathered impacts. Plastic pollution poses deadly risks, with turtles often mistaking plastic bags for jellyfish prey items. Rising temperatures affect sand temperatures, skewing sex ratios of hatchlings toward predominantly female populations worldwide. Coastal development destroys critical nesting beaches, leaving fewer safe places for females to lay eggs. Conservation and hope. Conservation efforts across the globe offer hope for the survival of these magnificent ancient creatures. Researchers tag turtles to track migration patterns, revealing previously unknown connections between distant ocean habitats. Protected nesting beaches provide safe havens where females can lay eggs without human disturbance or predation. Rehabilitation centers treat injured individuals, giving them a second chance at life in their ocean homes. These interventions, though crucial, remind us of our profound responsibility to protect these remarkable survivors. We must ensure that creatures who have survived since the age of dinosaurs continue navigating oceans. Every hatchling that reaches the water carries forward a legacy hundreds of millions of years old. International cooperation through treaties and agreements helps protect turtles across their vast migrational ranges and territories. Fishing gear modifications, such as turtle excluder devices, reduce accidental bycatch in commercial fishing operations. Public education programs raise awareness about the importance of sea turtles and their conservation needs. Community-based conservation initiatives empower local populations to become stewards of nesting beaches and marine habitats. The evolutionary legacy. The story of sea turtles is a story of endurance, innovation, and wonder spanning eons. From obscure terrestrial ancestors to masters of the marine realm, these creatures embody triumph through change. Each fossil discovery, each scientific observation, each conservation success deepens our appreciation for their remarkable resilience. Their evolutionary journey urges us to protect not only these animals, but fragile ecosystems they inhabit. Sea turtles demonstrate that evolutionary success is measured not in size, but in adaptability and persistence. They survived the extinction of dinosaurs, navigated changing ocean chemistry, and adapted to fluctuating climates. Their navigational abilities remain one of nature's greatest mysteries, with hatchlings returning to natal beaches decades later. Magnetic field detection, chemical cues, and celestial navigation may all play roles in their journeys. The study of sea turtles continues to reveal insights into marine biology, evolution, and ecology. Their physiology demonstrates remarkable adaptations, including the ability to hold breath for hours during deep dives. Salt glands allow them to drink seawater, excreting excess salt through specialized glands near their eyes. Their streamlined bodies and powerful flippers enable efficient swimming across vast distances with minimal energy expenditure. Sea turtles are living monuments to Earth's distant past, bridges between prehistoric oceans and modernity. Their survival depends entirely on the choices we make today, individually and collectively as a society. Each act of protection ensures their story continues for generations yet to come on this planet. In safeguarding them, we preserve a lineage that has endured countless epochs of dramatic change. We are reminded of the beauty, fragility, and extraordinary resilience of life itself on Earth. These ancient mariners have witnessed the birth of mountain ranges, the opening of ocean basins, continents. They have seen ice ages come and go, watched sea levels rise and fall repeatedly. They survived when countless other species succumbed to extinction events that reshaped life's diversity on Earth. Now, in the Anthropocene epoch, their fate rests in human hands more than ever before. We have the knowledge, technology, and moral imperative to ensure their survival for future generations worldwide. Every piece of plastic removed from oceans, every protected beach, every sustainable fishing practice helps immensely. Every child who learns about sea turtles becomes a potential advocate for their protection and conservation. The ancient odyssey of sea turtles continues, but only if we choose to be their guardians. Their story is our story, a reminder that all life on Earth is interconnected and interdependent. As we gaze upon these magnificent creatures, we see not just animals, but living history itself. We see survivors of unimaginable change, witnesses to the grand sweep of evolutionary time and space. We see the enduring wonder of nature and the responsibility we bear to protect it. Let us ensure that sea turtles continue their ancient journey for millions of years to come. Let us be the generation that turned the tide, that chose preservation over destruction and neglect. The ocean calls to us, and within it swim creatures who have earned their place forever. The ancient odyssey continues, and the story is far from over for these magnificent marine reptiles.